Um, I'm going to discuss object-oriented programming with C Sharp. In this video, I'm not going to discuss object-oriented programming from the scratch. Instead, I assume that you have already learned object-oriented programming with Java. Okay. And one particular purpose of this video is to revise your knowledge about object-oriented programming, and also you will learn the same concepts using C# programming language. And if you look at this, now you are already familiar with classes, the concept of classes. Then you know what is a constructor. Then the term properties is new to you. Okay, properties is new to you. Actually, in Java, we created getters and setters. So in order to achieve this purpose, in C# we have properties. Later we will discuss it in detail. And then we discuss about events. I think in object-oriented programming course, you have not learned about events. Okay. So in this video, let's discuss about events. Then static members, that means class members. Okay, so you are already familiar. Then with interfaces, you are already familiar. Okay, inheritance and polymorphism, you already know. And these are the two new things. Okay, and also many other new things, additional features in C# you will learn in this video. Okay. Now this is the table of contents. First we will discuss how we can define classes in C#. Then we will discuss about access modifiers in Java. If you can remember, these are the access modifiers: public, private, protected. Okay, these are the access modifiers in Java. If you do not specify an access modifier, then that member has default access. Okay. Then we discuss about constructors, and after that fields, constants, and properties. In Java, you have learned that in a particular class. Okay, class name, here you specify the class name. Okay, then here you specify the set of attributes. In other words, we call that the state of the class, and here we specify the behavior. Okay, and actually here the set of methods. Here we specify the set of methods, and we call it the behavior of the class. And for the attributes, for the term attributes, in C# we use the term fields. Okay, that is the term we use commonly used in C#. And now constants. Okay, constants and properties. I have already mentioned that the purpose of properties is in Java we had getters and setters. Okay, so in order to do the purpose of getters and setters, we use properties in C sharp, and then we will discuss about structures. Okay. Structures. And now you have learned C programming language. In C programming language, you have learned structures. Okay. In Java, you have learned about classes. Okay. So in Java, you had only classes. Java is a purely object oriented programming language. That means everything we write within a class, but C sharp is not a purely object oriented programming language. The class concept we can achieve using two things. Using classes we can achieve it. Okay, using structures you can achieve the class concept. Okay, so we will discuss structures in C sharp. Then new concepts like delegates and events we will discuss later. You will know what are them, what are they. Then interfaces you have already learned in Java programming language. Inheritance you have already learned. Then polymorphism, the same concepts, slight syntax differences are there, so you will learn the same concepts using C sharp programming language. Okay, then now let's discuss about object oriented programming and .NET framework. Okay, .NET means a framework. What do we understand by a framework? Framework means a set of libraries. Okay, so you have learnt about Java API. Then you may standard tag library of C++ programming language. You may have not heard about this one, but you have already heard about Java API, application programming interface. Okay, so actually .NET framework is a set of libraries, and now if you consider in .NET framework, the object oriented approach has roots in the deepest architectural level. Okay, so deeply we can perform object oriented programming on top of .NET framework, and all .NET applications are object oriented. Okay, if you consider all the .NET applications, they are object oriented, and if you consider all .NET programming languages, C sharp .NET, that is one particular programming language, then Visual Basic .NET, another programming language. Likewise, we have many other programming languages, and these all are object oriented. Okay, then the class concept from OOP has two realizations in C sharp, as I have mentioned. The class concept, one thing you can achieve it using classes, otherwise you can achieve it using structures. Okay, and now in Java we had only this one. That's why we call Java as a purely object-oriented programming language. But C# is not a purely object-oriented programming language. And the other thing is there is no multiple inheritance in .NET. So what do we understand by multiple inheritance? In Java, you have learnt about inheritance, and in Java also, if you have one particular class, it can have at most one superclass. Okay? In Java also does not support multiple inheritance. That means for a given class, there cannot have more than one superclass. This is not possible in Java. Okay, not only in Java, in C# also multiple inheritance is not possible. That means for a given particular class, either it does not have a superclass or can have exactly one superclass. That means a given class can have at most one superclass. Okay, so now classes can implement several interfaces at the same time. In Java course, you have learned that since Java does not support multiple inheritance, okay, since Java does not support multiple inheritance, in order to achieve multiple inheritance, okay, Java does not support multiple inheritance, but in order to achieve something like that, we can use interfaces. So a given class, even though a given class can have at most one superclass, okay, it can have any number of interfaces. It can implement any number of interfaces. Okay, it can implement any number of interfaces. Okay, so same as in Java, in C# also we have that. Then let's discuss how can we define classes in C#. Classes model real world objects and define. Okay, so if you consider a class, in the graphical notation of a class, we have three parts. Here we specify the name of the class. Here we have attributes. For the attributes, sometimes we say set of the attributes, we say the state of the class, and also we say fields, and we use the term properties. Okay, properties, but don't mess up this term with the properties I had mentioned earlier in this video. Okay, the properties that replace getters and setters, that is a different one. Okay, here we use the term properties for attributes as well. Okay, but this properties and this properties, two different things. Earlier I have mentioned about a different thing, different properties that can do the same thing done by getters and setters. Okay, so usually it's better not to use this term as a synonym for attributes, okay, since we can mess up, it can mess up with this one. Okay, so now here attributes, and here we have behavior of the class, and so behavior, actually here we should use the term state and behavior. State means the set of attributes, or we say set of fields, or we say, better not to say, a set of properties. And here behavior means set of methods, or else we say set of operations, like that. Okay, classes describe structure of objects. Objects describe particular instance of a class. That means, now if this is our student class, okay, so we may have attributes like name, age, okay, marks. Likewise, we can have attributes. So now if then for the behavior, we can have methods like calculate average. Okay, now now this is our student class, that is just a template, Now if you consider Nimal has a name is there. Okay, then age, let's say 20, marks 37. Okay, then this one is an object. Okay, this one is an object. Another object, Sunil, let's say. Now we have the name, age 37, marks 91. This is another object. Okay, so the class is just a concept. We cannot see students in the real world. That is just a concept. This is a template, and when we put values to the attributes, we can get objects. We can create objects from the class. And now this method does not have any meaning when it is inside the class, but if you perform this particular method, okay, for the objects, then only it can have a meaning. Now properties hold information about the modeled object relevant to the problem. Now the attributes, here the properties means attributes. Okay, attributes, they hold information about the object. Name, age, marks, likewise, they hold the information. Operations implement object behavior. Then operations like this, they use the available information and perform operations on those information. Okay, now um, let's move to the next slide. Now let's discuss classes in C Sharp. Classes in C Sharp could have following members. Now you have learned Java. Okay, in Java you have already learned about two types of members. One thing is there are attributes. An attribute is a member, a method is a member. Okay, two types of members, attributes and methods. But in this video you are going to learn about many members in C Sharp. If you consider a C Sharp, if you consider a class in C Sharp, okay, there we can have fields. Fields means that is a synonym for attributes. Then there we can have constants. Constants are there. Then methods are there. Methods. Properties. Here properties means those do the same thing done by getters and setters in Java. Okay. Then indexes are there, events are there, operators are there, constructors are there. Okay, destructors are there. Okay, so in addition to these, we have within a given class we can have inner types. Inner types, what are they? Inner classes. Within the class we can include another class. Within the class, inner classes are there. Then within the class we can include the structure. We can include the structures within the class. Okay. Then we can include interfaces. Then we can include delegates and so on. Okay, there are many other things are there. Okay, so now that's about the members inside the class in C Sharp. Then if you consider one particular method, maybe a field or a method or a constructor or whatever, any member, then we can have different types of access modifiers. In Java, we had private access modifier. Okay, then public access modifier, protected access modifier. If we do not specify an access modifier, then those members had default access. Now in C Sharp, what are the access modifiers? Public is there. Later we will understand there are slight differences. If you consider private, private, then protected, internal, these are the access modifiers available in C#, and there are slight differences because for an example, this protected and this protected are not exactly same. Okay, so there are slight differences. Let's learn them later. If you consider one particular member, okay, if you consider one particular member is static or is specific for a given object, in object-oriented programming in Java, you have already learned about class attributes and instance attributes, or class methods and instance methods. In the same way, in C# we have static, that means class members, and also instance members. Okay, that means static means class members, those are common to all the objects, or specific for a given object. If you consider an instance member, that is specific for a given object. Okay. Now let's discuss simple class definition. Now we use the access modifier public, we class public class, okay, then cat. In order to name classes, we use the camel case as in Java. Then this is this term. In Java, we had the keyword extends. Okay, that one. In C# we use the colon, and this is here we specify the super class. Now you know in C# multiple inheritance is not available, therefore here you can have only one class. Okay, now cat class inherits from animal class. Okay, now we use braces. Private string name, this is a field, private string name. In Java we did not have a string data type, instead we used string class in Java. Okay, but in C# we have string data type. Here we have used that one. Okay, then private string owner. Okay, then we can include the constructor public constructor. The name of the constructor, that should be exactly similar to the class name, and here we do not have a return type. Okay, in the parameter list let's include these two. Okay, then string name, string owner. Okay, now since we have used the same name as the field, now in order to distinguish, we must use this keyword. This dot name means now it refers the field. Okay, now if you use just name, it refers the parameter. And now here this dot owner, owner. This dot owner refers this particular attribute and owner refers this particular parameter. Okay, that is our constructor. Constructor is not going to return anything, and also we do not specify a return type. Here the name of the constructor must be exactly similar to the class name. Then we have this public, new thing to you, okay, public string, public string name. Now this is actually a property. That's what I was talking. In Java we had getters and setters. In C# also we can create getters and setters, but they have a special feature, a special type of members called properties. Okay, so here now we can include two parts, get then here return return name, return name, then this is the set part. Both getter and setter is inside this property. Set part name value. So later I will discuss this in detail. For the time being, just try to understand that now in order to include a property for our name field, then we usually in C# and also in Java we use camel case for the fields. Okay, so when we create the corresponding property, we make the starting character capital. Okay, we make the starting character capital. Then let's say now this is our property, and in order to close this this one, okay, then these are the names: begin of class definition, inherited or base class. This is called the base class or super class. Okay, then these two are fields. This is called a constructor. Sorry, this is called a property, and this is the rest of our class. So I will write down the rest here. Okay, so you have to think after this, then we should have this one, public string owner, so that is for our owner field. There we include get part, return owner, set part, owner value. Okay, so another, now we include a property for name attribute, name field, then another property for our owner field. Now we include a method, public public void, return type is void, same meow. That is that is actually how then cats how cats make sound. Okay, so they say meow. Okay, something like that. So console dot write line you, okay, like this, and then this is the brace, and now we have to close it. Okay, now let's see. This is a method, and this brace is the end of our class definition. Now let's discuss about classes and the members. I have already mentioned these things. Classes can have members, fields are there, then constants are there, methods are there, properties are there. Now here we have two fields, a constructor, then two properties, and one particular method. Okay, so in that way classes can have members, fields are there, constants are there, methods are there, properties are there, indexes are there, events, operators, constructors, destructors, and so on. Then within a class we can have classes, and also we may have structures, interfaces, delegates. Okay, likewise we can have members. Members can have modifiers. In C# we have public, private, protected, and internal access modifiers, and then members can be either static or non-static. That means a class member or an instance member. Okay, then let's move to the next slide. Class definition and members. If you consider class definition consists of class declaration part is there. Here we declare the class, inherited class or implemented interfaces. Now after this colon, here we include the super class, or if you have any interfaces you can separate the interfaces from commas and include here. Okay, so then fields we can include, if they are static fields we can specify them from static keyword. Okay, then constructors are there. Here this is a non-static constructor, and later you will learn actually in this course there can have constructors. There we can create static constructors as well. Later when we discuss a concept called design patterns, then you will learn about static constructors. Then properties can also be either static or non-static, and methods. In Java also you have learned about class methods and instance methods. In the same way we may have class methods and instance methods. Then events, inner types, those things are also there. Okay. Now let's discuss about access modifiers. Now you already know what are access modifiers, and actually this lesson is not to teach you object oriented programming from the scratch. Now in your Java course you have already learned about access modifiers. Okay, in C# also we have access modifiers. Class members can have access modifiers used to restrict the classes able to access them. Okay, so in one particular class, if we specify certain access modifiers, then actually we restrict other classes from accessing that particular member. Okay, so support the double OP principle encapsulation. Now there are 4 principles of object-oriented programming. In Java clause, you have already learned those 4. Encapsulation is one of them, and access modifiers can facilitate encapsulation by performing data hiding. Okay, and if you consider one particular class member that can be public in Java, public, the same thing in Java also. If you use public access modifier, that member can be accessed from any class. Okay, in C# also we have the same thing. If you put a public access modifier for a particular member, that member can be accessed from any other class. And if you use protected access modifier, accessible from the class itself and all its descendant classes. Okay, so if you consider one particular class, okay, there, let's say, if you consider one particular class, there, let's say we have a member with protected access modifier. That member is accessible within the class itself and also from all its descendant classes. Okay, from through all its children, this member can be accessed, and this is somewhat different from Java, because Java, it says within the same package, classes within the same package also can access a protected member. But here if you use the protected access modifier, accessible from the class itself and all its descendant classes. Okay, package thing is not here. Okay, and private means accessible from the class itself only, and in Java also private access modifier means we can access that member only within that class itself. Okay, then if you if you use internal access modifier, accessible from the current assembly. Okay, assembly for the time being, let's say your project. Okay, within, for the time being, you understand assembly as your working project. Okay, so if you use internal access modifier, that member can only be accessed within the current assembly. Okay, now let's move to the next slide. Then we are going to discuss an example. How to define classes. Okay, our task is to define a class dog. Our task is to define a simple class that represents information about the dog. The dog should have name and breed. So there will be our two fields. If there is no name or breed assigned to the dog, it should be named Balkan and its breed should be Street Excellent. Okay, so it should be able to view and change the name and the breed of the dog. The dog should be able to bark. Okay, so those are the information. Now let's see. Now here we have public access modifier, then class keyword. This is the name of our class, and now private. This is the access modifier. Okay, so this field, now we use the string data type, and name. This field is accessible only within the class itself, and private string breed. These are the two fields. Then we include a constructor public. We do not have return type dog, empty parenthesis. So now this dot name, this one is called Balkan name. So this dot breed Street Excellent. That means if you invoke this particular constructor to create an object from this class, then these two fields of the object will initially contain these two values. Okay, then we create another constructor public dog, and this is a constructor with parameters. Now we have two constructors with the same name. Definitely name should be same, because if we create a constructor, the name of the constructor must be exactly similar to the name of the class. And here is string name. Okay, string name, string breed, those are the two parameters, and we have used the same words as the fields. Therefore we must use this keyword in order to avoid ambiguity. Then this dot name, okay, then this is this field, and now here name means this attribute, this parameter, sorry, this parameter. Then this dot breed means breed. Okay, this dot breed, that means this particular field and breed. Okay, so now we have two constructors. Then we, let's say, here now to this field I am going to include a property public. For the property here, for the field, we have used private access modifier. That means that field can only be accessed within the class itself. From the outside we cannot access. In order to access from the outside, now you have learnt in Java, we use getters and setters. Okay, usually attributes are private in Java, then methods are public usually. Then when we have to create getters and setters as public. Okay, in the same way, the properties are public here. Okay, not a rule, but usually we create public properties. Then this is the type, this one. Then we use capital N and then name. Okay, then after that we have two parts, get and set. Get part is our getter part. Okay, there we return name. Okay, then set name, we assign value like that. Okay, then after that, so below that I do not have enough space, so I continue writing here. Now for this particular field, we create public type is string, capital B, breed. Okay, that is just a convention. Now we have two parts. In get part, what we do is we return the value of the field, return breed, set breed to the value. Okay, then after that we can include a method. I will write it here. Okay, so public void, the return type is void, say bow, BAU. Then after that console dot write line here, this one, it is now you have learned C. There I think you have used this. Okay, the same purpose is here using this particular symbol. Okay, then said okay, you have to write this in a single line. Okay, a single line. Now okay, so now if you look at this class, two fields are there, then two constructors are there, two properties are there, and one method. Okay, then let's move to the next slide. Using classes and objects. how to use classes, create a new instance, access the properties of the class, invoke methods, handle events. So if you consider one particular class, one thing you can do with the class is you can create any number of instances, that means objects. Access the properties of the class, that means once you have created objects, then you can access properties. Here properties means actually fields. Okay, then we can invoke methods with respect to those objects. Okay, then we can handle events. Okay, then how to define classes: create new class and define its members, create new class using some other as base class. That means we can create a class and include members, or else we can inherit from members from a given class. That process we call as inheritance. You have already learned in Java. Okay, now let's move to the next slide. How to use classes, non-static classes. Create an instance. So in order to create an object, we can assign values to the fields. Then we can manipulate the instance. Here instance means our object. Then read and change properties. Here properties means fields. We can invoke methods, we can handle events, release occupied resources done automatically in most cases. Okay, so when a particular class when particular object uses particular resources, then we can release them. Okay, later you will understand these things in detail. Okay, then after that our task is as follows. We have to create 3 dogs. First should be named Sharo, second Rex, and the last left without name. Add all dogs in an array. Iterate through the array elements and ask each dog to bark. Particular note is there, use the dog class from the previous example. Sorry. Now here we have to use static. This is our main method, static void main. Okay. Now here console.writeLine enter first dog's name. Then using the readLine method, we read user input. Then breed also we read. Okay, and after that, okay, those things here we do. Okay, after that, then this one, dog. This is a reference. To this reference, we assign this object. We use the new keyword, new dog. Then here, dog name and dog breed. The values of these two we pass. Dog name, dog breed. Values of these two. Then another dog. Sorry, here not just dog. First dog. So here dog. Second dog, new. Okay, this one. Then now we in the second dog, actually now if you look at our dog class here, in this situation we have invoked this particular constructor, then the user's values will be assigned to these two fields, and in our second dog, in this particular object, we will have Balkan for the name field and Street Excellent for the breed field. Okay, now let's see. Then again what we do is second dog's name, user input is taken, second dog's breed, user input is taken, then second dog dot name, second dog dot operator name. Actually this is the property we access in our dog class. To this we assign dog name, okay. So user input will be assigned. Now in our second dog here, Balkan was the name. Now we change it to the user input. Second dog breed, this is the property, then here we access it dog breed. Okay, then that's how we should do it. Then let's move to the next slide. Let's discuss about constructors, defining and using class constructors. Then let's try to understand what is a constructor. Constructors are special methods, okay, invoked when creating a new instance of an object. Now using a given class, if we want to create an object, then we have to invoke a constructor. Okay, there can have more than one constructor in a given class, so we can invoke a constructor used to initialize the fields of the instance. Okay, using the constructor at the creation of the object, also we can assign values to the fields. Okay, constructors has the same name as the class. Okay, name of the constructor should be exactly same as the class name. Have no return type is not there. We can have parameters, can be private, protected, internal, public. Okay, we can put any access modifier for a constructor. Okay, now let's discuss about how to define constructors. Then here, class point with parameterless constructor. A point means, now if you consider two-dimensional space, if you consider one particular point, then it has two fields, x coordinate and y coordinate. Okay, x coordinate comma and then y coordinate, x coordinate and y coordinate. So we use this field. For the x coordinate, for the y coordinate, we use this field. And now simple default constructor. That means in Java you have learned that if we do not include the constructor, if we do not include the constructor in a given class, then Java compiler automatically creates a constructor for us. That constructor is called the default constructor. Okay. Default constructor is the constructor that is automatically created by the compiler in the absence of user-defined constructors. In the C# also we have the same thing. If we do not include our own constructor to a given class, then the compiler, the C# compiler will automatically create a constructor for us, and that constructor will assign default values to the fields. Okay, so now actually here we use the term default. Actually this does the same thing done by the default constructor. Okay, because if you invoke the default constructor, now default value for int data type is 0, therefore both fields will be assigned 0. So this constructor does the same thing done by the default constructor. Okay, then we can include more code there. Now if you consider person class, okay, if you consider the person class, then you have two fields, private string name and private int age. Now we can create a constructor. Actually default constructor term is not suitable. Let's say we include a particular constructor there. To the name field we assign no name, this part. To the age we assign 0. Then another constructor, here the name should be exactly same as the class name. Okay, and then we can pass values to the name and age fields and create an object using this particular constructor. A rule constructor should initialize all own class fields. That means when you work with inheritance, this rule is important. Usually if you use a constructor, it should initialize all the fields available in that particular class, not the inherited ones, what we have included, what we have typed inside that particular class. Okay, those fields should be initialized within the constructor. Then this is another pay attention when using inline initialization, public class clock alarm, private int hours 9. In a class we can do this. Okay, here we have assigned a value. Here we have assigned a value, and private int minutes we have assigned a value. That does not mean a class fields usually do not have values. The meaning of this one is when we create an object from this particular class, in that object initially the hours field will take the value 9 and minutes field will take the value 0. Okay, that is the meaning of this kind of initializations. And now this is a constructor. If we keep these braces empty, that means this constructor will assign default values to the object. Now here the default values are 9 and 0. Okay, because we have explicitly given values, then okay, therefore in this situation actually ours will not be 0, okay, because we have explicitly assigned values. Now these two values are the default values, okay. Then we can include another constructor. Here we pass two values, and using the users values we can assign them to the fields, okay. And now chaining constructors calls, that is another thing. Now we have point class. There we have two coordinates, x coordinate and y coordinate. Then this is our constructor. There actually what you should do in this constructor, our purpose is this one: public point okay this dot x code 0, this dot y code 0. Actually what we need to do is this one, okay. So we can use this particular constructor, okay. Instead of doing this, we can use this constructor, and okay, here we can use the colon and this keyword. This keyword refers now the constructor. There we pass 0 comma 0. In this situation, this this one invokes this particular constructor, okay. That's what happens. Therefore that is another way. Now let's discuss about fields, constants and properties, okay. Fields, constants and properties. If you consider fields, fields contain data for the class instance. Now we have already worked with fields. Here we can see an example is string. Data type is string, first name, last name, then int course, specialty, then this is an array. Course is another class, then an array of references, okay. Private string remarks, this is another string. Fields contain data for the class instance. There is one particular thing. Then can be arbitrary type, whether it is an integer, string, char, or whatever. Have given scope, we can specify the scope using access modifiers. Can be declared with a specific value, okay. Constant fields are defined like fields, but defined with const keyword. If it is a constant, we use const keyword, okay. Now must be initialized at their definition. Their value cannot be changed at runtime, okay. That means if you use something like this public, we use the const keyword, const, then we have to write the data type. Data type is string, pi symbol, Okay, then if you execute this line of code, this will give us an error because we have used the const keyword but we have not assigned a value at the time of declaration. At the time of declaration we have to initialize. Okay, therefore we have to assign a value to the field. Okay, then once you have done this, if you try to change, for an example, later you try to execute this one. Okay, then this line of code will give us an error because this is a constant. We cannot change it later. Okay, so that is about constants. Then another thing, read only fields. Initialized at the definition or in the constructor cannot be modified further. Defined with the keyword read only, represent runtime constants. That means once we have done this private read only int size, so we can declare it in this way. Then size 5, this is okay. Then again if we try to assign another value, this will give us an error because if you create a field with read only modifier, then we can assign a value to that field only one time. Okay, we are not allowed to modify it again. Okay, this is one particular way, or else we can do it in this way as well. Here you assign a value, let's say this one, then we have assigned a value. So again if we try to assign a value, this will give us an error because we are not going to modify it again. Assigning a value can be done only one time if it is a read only field. Okay, these are important when we discuss about design patterns. You will find this information useful. Then we discuss about properties. Now we have to some extent we have discussed about properties. Here we are going to discuss it in detail. Expose objects data to the outside world. Usually in when you were learning Java, you have learned that attributes are private and methods are public. Then getters and setters are also methods. They are for public, and they through the getters and setters we can access the attributes. So here what we do is in C# we usually fields are private, then properties are public. Through properties we can access fields, those private fields. Control how the data is manipulated. Properties can be read only, write only, read and write. Now earlier we have used get set. Two parts were there. If we have only if we have both these parts, read and write, it is a read and write property. Earlier we have used read and write properties. If you include only the get part, we can get only get a value. It is read only. We cannot set a value for the field using that property. Okay, if you include only the set part, then we can only assign a value to the field and we cannot read it. therefore it is a write only property. Okay, then give good level of abstraction. Okay, so good level of abstraction we can achieve using properties. Make writing code easier. Unlike using getters and setters, now when we use properties, now our code is smarter. Okay, defining properties in C#, properties should have access modifier should be there, public, protected, etc. We have to specify an access modifier. Then we do not specify a return type for a property, and a unique name should be there. Get and or set part can contain code processing data in a specific way. In a property, we can include code processing parts as well, not only just assigning values to the fields. Okay, now here in our class point, now we have two fields. Here for the x coordinate we have created the property read write property, we have both parts. Then for the y coordinate we have included a read write property. Okay, now let's move to the next slide. Now these are, yes, this is another type of properties, dynamic properties. Properties are not obligatory bound to a class field, can be calculated dynamically. That means if you have this kind of two fields, now even without an underline field, we can have a property public float area. This is a read only property because we have only the get part, and now here return width into height. Okay, so here we return value. So now we have not created the field called area. Okay, it is not necessary. We can create this kind of a property even without an underlying field. Then these are called automatic properties. Properties could be defined without an underlying field behind them. It is automatically created by the C# compiler. Okay, so now it is like this, the same thing we have discussed, and now public int user ID get set. Okay, now this is a read write property user ID. Now we do not have an underlying field. We do not have to create a field called user ID. It's not necessary. If you write this line in our code, then C# compiler will create a corresponding field. Okay, so we can simply create properties even without underlying fields. And now if you want to create an object from this class. Okay, if you want to create an object from this class, what you should do is user profile. That is the name of our class. This is the profile. This is the reference variable. New user profile. First name, is Steve. Now it will be assigned to the underlined field of first name. Then last name, Bomer. It will be assigned to the underlined field of this one. Then user ID, it will be assigned to the underlined field, this one. Okay, it is something like that. So now I hope you understand that we can create directly, we can create a property, and underlying fields will be automatically created by the C# compiler. Those fields are not visible to us, but they are available. Okay, then let's talk about static members. Now in Java you have learned about class attributes and instance attributes, then class methods and instance methods. Okay, in C# also we have both static and instance members. Static members means class members. Okay, static members are associated with the type rather than with an instance. Defined with the modifier static, we use the static modifier. Static can be used for fields, properties, methods, events, and constructors. We can use the static keyword and make them class members. Okay. Static versus static versus non-static. Static means associated with the type, not with an instance. Okay, associated with the type, not with an instance. That means a class, if you consider a class member, we say the class member is common to all the objects. That means class member is associated with the class, not with a specific object. The non-static means the opposite of that, associated with an instance. Okay, static initialized just before the type is used for the first time. Non-static initialized when the constructor is called. Now initialized just before the type is used for the first time. If it is a class member, that is initialized just before we use it for the first time. But if it is an instance member, if it is an instance field for an example, then it is initialized when we call the constructor. Okay, now if you consider this particular class, then this is a constant, therefore we have to initialize it at the time of declaration, and also we are not allowed to change it later. Static field, now here private static and array, integer array, square root values, sqrt values. Okay, now we include a static constructor pre-calculated. Okay, then here new max value plus 1, we create an array. Now using a for loop, for each value we compute the square root of the number and assign it to the corresponding value after typecasting. Okay, this square root value, it is a double, and now this one is an integer, therefore we have to typecast. Okay, now here we have included a static method. Now this one we pass the value and return the corresponding value. Then this is our main method. Here we compute get sqrt and pass the value. Okay, that is a simple example. I hope you can easily understand. Now that's the end of this particular video, and in the next part, in part 2 of this particular video, let's discuss about structures. And now thank you for watching the video.